Okay, so we are now 24 hours ahead of where we were before, or thereabouts. So in the end, I carried on with this till about 9 o'clock at night, and the result is now that we've got all the connectors on here now, and I've done a few of the fixing wires just to fix some of the issues, but it was getting late, it had been a long day, and I was clearly getting frustrated with trying to solder through this, so I decided the best thing to do was stop. Because now all the components are in now, this green solder mask will have hardened quite well now, so actually it's going to be very hard to solder through. But that's fine now, because everything I need to do now is going to be about actually either remelting these joints or putting some jumper wires over. So soldering is a mess, and I think the thing I've definitely spotted is that I needed to have the iron on a higher temperature, so 350 degrees centigrade in the end was probably the best temperature. I think if I do this again, there's definitely several things I will change, and if I do decide to do the register boards as PCBs, they're probably going to be double-sided, so I've already started looking at the circuitry for those and trying to design them, and there'll be lots of places where the tracks would need to cross, and that's going to be double-sided, and that's going to be a lot harder. So whereas this one's been quite straightforward, there's just nothing on the other side, the other ones will be a lot more involved. But you know, we'll have a think, see how we go. Right, so what I need to do now is probably just test this board properly. So I was doing it with a multimeter last night, but actually I think we can be a little bit cleverer about it. So what I have is a little board I've been using on some of my previous videos, and it's this one. So what this is basically just is a row of switches down here that are all connected to power, and then basically a row of LEDs down here coming back in again. So the theory is if I connect this up to some power, I can basically send some signals down this cable and then basically plug this into one end of the board, plug this into various ports, and just see if all of the connections are coming through. That will also help me find then any cross connections that are going on and anything I need to fix. So I've got my soldering iron warmed up ready to go for that, just in case there are any fixes need to be done. So what I'm going to do is I've got my 12 volt power supply just up here off camera, up there somewhere. So I'm just going to bring in the positive and negative terminals, just connect those down here. And they look good, nothing shorting. So if I pop the power on there, what I'm expecting to see is if I bridge this into here, to the right one, should get all the LEDs on. So that's obviously a good test. That means that basically all of the connections there are connecting. I don't know how well you can see that. The LEDs there, that's not too bad. Might just tilt my light off a little bit, and then basically if I connect them all up like so, you get all the lights. Yeah, you can see that a bit better. Cool, okay. So what I should be able to do is if I pop that into this connector down here, it's going to be difficult to show you properly on here because there'll be lots of things blocking the camera. But basically if I connect these now into what I think is this one here, there you go, I get all the lights, which basically means all the connections are working as they should be. And if I go down the board, I get all lights on there, all on there, all on there, and then if I go to the last one, I get them all on there as well, which is good. Now if I leave that one locked in, what I should then be able to do is if I knock these lights off one at a time, they should go off in the right order. And basically what that's telling me then is if there's any bridge connections, I should be able to spot them. So if I bring those back on again, they're all fine, and they're coming on back in the right order, which is good. So the next thing then will be to test the upper part. So that was the lower part. So if I now move this header strip and connect into the next row of pins, I should then find that going for this back part of the socket gives me a connection, which it does. So that's all good. And again, if I go down the board, I should find I've got a good connection all the way down, which I have. If I leave that on the last one, again, I can just cycle through these again. So if I take them off, they should go off in order, like so, and then come back on in order. Good. Okay, that's all looking fine. Now the one other thing I need to test for is then saying, well actually if I put this into the wrong socket, do I get any lights? And actually I do get one light, which basically means that one of these lines is cross-talking to the other, and I think it's number 2. Yes, number 2 is going to number 3, and what I would expect is that if I transfer this back to the side, so I get all lights, and if I go to the other socket on here, it would be number 2 that will come out, which makes sense. So basically what it is if I move this out of the way, I know then that what I'm looking for is a bridge between these two connections here, which is going to be quite hard to see, but yeah, just there and there. And actually, sure enough, if I look close up, I did spot one earlier where it was a bridge. Yeah, so this one just there is bridging over to the track above it. So all I need to do is basically just get in with a soldering iron and just try and remelt that and just stop it from bridging over to the next track, which I can do now. I can just see there's just a little bit of solder just linking over to the next track. Cool, I think that's cleared the track. So what I should be able to do now is plug this back in again, and I should get the reading I'm expecting. So again, all there, still all there. If I go all the way down the board, I should still have good readings. But if I go into the other socket now, there should be nothing at all. So there's no crosstalk there, which is fantastic. So that means from this socket, going down the board, we have all the connections we need. So what I'll do now basically is go through each of these sockets and then turn the board around and come in from this side and just look for any more faults on the board. But so far that connection there is a-okay. So I'll do this as a time lapse just to quickly take you through it, and then I think basically we have a working board. Okay, so that's it. That's the board pretty much fully tested. So there's a few more wire links I had to add. So there's one down here. This I did see a pad was slightly broken over there, so there's a wire link for that one. This one over here, I've no idea why there's a break on there, but for some reason there is. But anyway, they're all done. So let's have a bit of a closer view of these now. So if I zoom in, you can just see just how messy some of this solder is. So there are some definitely joints that aren't as well adhered to the board as they should be, and I just don't think I've got the iron hot enough for those. I mean, generally it's not too bad. There's some sloppy working places, but the main thing is it's going to work. So in theory now, all I need to do now is just drill these bigger holes here, and then I can put the mounting hardware in and then put it inside the computer. Now just put this zoom back in again on the board. There we go. So some things I've just thought about while doing this, actually. I think soldering for the green coat has been okay, but it has made it a little bit more difficult. What it suddenly occurred to me is that I could have just put some masking tape around these blocks here when I sprayed it, and then just peel the masking tape off. So that would have been quite good. That would have made some areas where the tracks were exposed and the rest of it was kept green. So that's possibly another option. Especially up here as well, it'll save me trying to solder through the green coat. The other thing as well is, of course, using the stackable headers has meant that these have been a lot harder to solder. So again, if you use the proper mounting hardware, that would make a big difference as well. I think one thing I might consider with this as well is, because I've looked at the tin on here as well, and the tin and copper, and it does have sort of micro holes in it, and I know that is a thing that when you're using toner transfer, the toner itself has micro little pits in it and little gaps, so consequently that transfers through to these larger areas. And I think one way of getting around that might be to actually use a different method of transferring the design over, which is to print it onto like a overhead projector sheet, like an acetate sheet, and you can print out 2 of them overlay them so you get a nice dense image, and then use UV, so you actually have the boards that have like a UV sensitive layer on them, and then basically what you do is put that on there, have a light box that will expose it, and then you can wash away then the bits that haven't been exposed. And the interesting with that is if I go for that method, I could also do the same for the solder resist as well. So actually then I could start using a UV sensitive solder resist as well, where you either can paste it on, or you can have like a dry film layer that goes over it, and then you can expose where the pads need to be, and then that washes off, so that also gives you a case where the pads are just exposed. So that's possibly another thing I can do. So I guess has this all been worth it in the end? I mean, I won't say it's been fun to do, but it's been interesting. It's been interesting to do this. I suppose I've learned a few new skills. The another thing is I could get this professionally done, like for I can't remember what it was now, about £5 a board or something. I'm kind of tempted to get one of those and just get it, see what it looks like, and see how it turn out. I think for the register cards, I think I might have a go at doing it by hand, and then if that really goes wrong, I'll just buy them in. I do feel a bit guilty about buying them in as well, because it's almost like I'm cheating. I'm making this computer. The kind of whole thing with this computer is that I've made it myself. I've built it all myself. There's a lot of me in there. And if I get these boards done professionally, it's kind of, well, is that cheating? I'm a little bit torn on that. I mean, this is very handmade, and actually doesn't look that bad. Actually, sometimes I look at it and think it looks quite good, and then other times I look at it and think it looks awful. But anyway, I'm wittering on now. So I think the final thing to do now is to, as I say, drill these holes, mount it to the computer. So I think what I'll do is I'll do a video of doing that, because then I think that is the end of this card. And we'll see how we go. Now, whether I replace the other 3 cards is another matter as well, because I could do a similar design for the W, the X and the Z backplane, and make those by hand as well. And I still have a piece of copper spare, because amazingly this would work first time. So bear in mind, this is what this started off like. It just started off as a piece of copper. Actually, I suppose, it's gone through quite a long journey. But I could do another backplane, so I'll consider that as well. Cool, alright, well, let's move on to fitting it into the computer.